The idea of today is motivated by a crop of papers that have been appearing that try to study the relation between language, or linguistic capabilities of humans, and programming. So a very cool paper that I found out like less than a month ago is called Comprehension of Computer Code Relies Primarily on Domain General Executive Brain Regions. Okay, what does it even mean, right? For us that are not into neurolinguistics or neuroscience. This paper is by Anna Ivanova and more people you can see there. So first, the goal here is not to criticize the paper, okay? This is not, this paper is valid, it's not valid. I am no authority to say if this paper is or isn't, okay? So let's cut this from the beginning. That is not the goal. The goal is because, as you know, besides that I actually studied linguistics back in the day before being a programmer. I probably have way too many books about the topic, okay? So when I read these kind of papers, also I'm a programmer since more than 10 years, I wonder what do they mean, what are they actually trying to measure, and so on. So I have a lot of questions for the author of this paper and related papers that had appeared in the last 5 years, let's say. Some of them are mentioned in this paper, some of them you can find them online. The actual papers are not the point. The point are to see questions that can help us and maybe help researchers understand and clarify what they are actually measuring. Some of these questions that when I started reading this paper, even before I had maybe like a list of 30 questions, some of them are addressed in this paper. They are answered by the author, so that is really cool. I was super surprised in a good way when I see all this in the paper. For me, I was like, wow, finally a paper that goes into the details. Many papers that appear before, some of them, as I say, mentioned in this article or paper, don't. So it's really hard to say, okay, you're talking about code comprehension. What do you mean by code? What do you mean by comprehension? What do you mean? Okay. So let's go to a brief summary of the paper first. The paper discusses fMRI studies, so magnetic resonance imaging. I think that's the English word, and the F stands for functional. I may butcher this. You can for sure go to Wikipedia, but basically they study how the blood flows in the brain, how your blood works there, see which regions of the brain are active. Based on that, they can say, okay, if I'm moving my arms, this region is active. If I'm reading a book, this other region is active. For sure, this is an oversimplification. If anybody that is doing the neuroscience is actually watching this, they already probably stopped the video. So yeah, I'm super oversimplifying in the same way that I'm actually oversimplifying what this paper is actually talking about. So if you are really interested, please go and check it out, right? Anyway, the paper talks about two systems that are in the brain. One is called the multiple demand system that is recruited, as they say in neuroscience, during math, logic, problem solving, and executive tasks. This system was not developed because it's already there in the brain, but this system was kind of not organized, defined maybe. I don't remember exactly the name of the author, but it was around the early 2000s that scientists came and say, okay, we have all these regions in the brain, they are at work or recruited during math, logic, and so on, all these problems. And I want to call it the multiple demand system, okay? Then there is the language system. And this system is recruited, as it says, during linguistic processing. Usually what I read, there might be more details into this, but basically is in the front side of your brain. So what they are trying to see is by using Python code and Scratch code, which Scratch is a visual programming language, Python is textual, is to see when they present the subject with these problem codes inside an fMRI machine, they try to analyze which part of the brain are active. And they found that the MD system, so the one for math, logic, problem solving, and executive tasks, is the one that has stronger responses in this experiment, while the language system didn't. So this is basically the big picture of the paper. Can we say that the language or that we don't use language when programming? I don't know, because again, this paper is measuring very specific things, and we are going to try to understand those. Sorry, about the actual, not result, but about the way they interpret the results, how the experiments were set up and so on. I am not the person to discuss that. If you want to see that, go to the link there, eLife Sciences, or below you can find the criticism that this paper found. I mean, when it was submitted for review, what the reviewers said. And there you can see a discussion of the actual methodology used in the paper. I am not going to discuss that except for one point that is not covered in the paper. So anyway, let's get into some comments about the paper. And again, this can be applied to any paper that is related to this. And again, these are just my questions, a random dude on the internet. I am not saying this paper is right, this paper is wrong, or they need to change, I don't know what, because that's not the goal here. Anyway, so I want to understand what are you measuring, right? That is my biggest question. So, first question. There is this book called Linguistic Relativity by Caleb Everett, where he says that this author, Heinrich Heine and Norensayan, in 2010, talking about the different studies related to the human brain, perception, visual, and whatnot, is that most of these studies center themselves on weird subjects. So what are these weird subjects? Are Western, educated, industrialized, rich, and democratic people, okay? So this is not discussed in the paper. I checked the form they made the subject fill in. As far as I understand, they don't ask these kind of questions. For me, from an ethical point of view, it will be great that this becomes a standard, that your paper says, I'm studying weird subject, yes or no. And in that sense, we can limit to who these results apply. Okay, so that is one detail. And why does it matter? So there are a couple of books by Lakoff and Nunez, and also Lakoff and Johnson. I will give the titles later. But from these books, I wonder, when I see these kind of papers, which kind of metaphor scaffolding is required for understanding code? And I will go to that soon. Then second thing that was not covered in the paper, how many languages do these people speak? I mean, the subjects involved in the experiment, and why this might be important. And there is another book there from psycholinguistics. And finally, what about cultures with no writing systems? Yes, I know these cultures won't be reading code, but are their experiences relevant in some way for computation? Do they have algorithms or recipes they follow, or recipes? Do they have computational thinking? I know, as far as I understand, that this particular paper is not evaluating computational thinking. That is at a different level. Computational thinking is something that, as they explained, started by Janet Wing. If you don't know Janet Wing, you probably know the Liskov substitution principle. Actually, that principle was developed by Barbara Liskov working together with Janet Wing. So Janet Wing, again in the early 2000s, developed the idea of computational thinking about all the things we do when we solve problems with computers, like separating the problems into tasks, thinking algorithmically, let's say, and all those things. You can hear stuff about computational thinking. So while computational thinking may not apply to this particular paper, maybe it does to others that try to study language and programming. That's why I have that there. Because many times it sounds, I'm not saying that the paper is saying so, but then we read about these papers in some more like science, popular science blogs and portals that they publish saying like, language is not used in programming, or when we program, we blah, 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 blah. Okay. Those conclusions maybe are not even in the paper, but in the case there is this kind of conclusions in those papers, I want to, I think they shouldn't make like universal claims about the study, but actually say this happened with, let's say, weird subjects, okay? Which, by the way, I think weird is a really, really great acronym. Anyway, so are the subjects weird? Lakoff and Nunez, they publish a book called Where Mathematics Come From, that is from the year 2000. And they also publish, Lakoff with Johnson published Philosophy in the Flesh, 1989. So there are two things, and I am talking about both books at the same time, okay? But from Where Mathematics Come From, this book tried to analyze the way in which, or which kind of metaphors we use whenever we do math, okay? Which, by the way, I didn't put this in the as a question, but when they say the MD system uses math logic, okay, what area of math are we talking about? Or what area of logic are we talking about? We could talk about this later, but again, sometimes I find the papers to be underdefined or underspecified. So in this paper, Lakoff says that we have a lot of metaphors that are in place when we understand a mathematical concept. For example, I can say the number line, and I trace a line, and I see a line. That line is a metaphor. The numbers aren't a line. Or if I say 7 is bigger than 4. Well, 7 is not bigger than 4. 7 is just 7, okay? And why I make my hand higher and lower, right? So in this sense, they say we have a lot of scaffolding. So one metaphor on top of another, that's a metaphor again, on which I use to understand math. So I wonder which kind of metaphor scaffolding we are using when we read code. One metaphor that I think I will talk about it later is the lines of code and how they are successive one after the other. We will see that later. Then in the Philosophy in the Flesh, they discuss the idea of time, and actually there are cultures in the world that are anumeric. It means these cultures, they don't have numbers. So for numbers are very important, for example, when we want to count time. And when it comes to time, we conceptualize time using space. And we have that in Aymara, a language from South America, time is conceptualized completely different. So why is this important? If we conceptualize time as space, if you look at the text where I have words in italic, these are metaphors, right? So it says, talking about any kind of event, that's all behind us now. Let's put placing something that in the back of us, that is for sure both of them talking about the past. We are looking ahead to the future. He has a great future in front of him, okay? So first, they say that in Aymara, this is completely the opposite. For Aymara people, the past is in front. So all these metaphors that we have here in, let's say, in English, also in Spanish and most European languages, they don't work in Aymara. So how does this scaffolding of metaphors affect the way we read and understand code? That, I think this is a huge question that at some point needs to be answered, okay? So let's keep going. So we have this metaphorical scaffolding that I said, and we talk about code and line numbers, which for a better example, I should have placed line numbers in this actual code snippet. But, sorry, the question is, imagine, because I forgot to add line numbers, imagine there are line numbers there. This is a sample code from this book. I almost threw my computer. This is Java. Concurrency in Practice is like the standard book for concurrency in Java by Brian Goetz. So this code, if runs in multi-thread, in a multi-thread environment, this code has a bug. Because when we reach the return value plus plus in public in getNext method, right? Value will actually be get from memory, I think incremented and then put back in storage. If two threads access this code at the same time, they can modify value in ways that are not as expected. In the usual bank application example, we can be modifying the money somebody has in their account in a non-concurrently safe way, and then we have bugs there. Point being that because of the earlier computers being sequential and single thread, we are used to think that code is going to be interpreted in a line, in a sequence of line numbers from top to bottom. That might not be the case. And in the case of Java, which is a programming language that has a just-in-time compiler, the compiler may decide to optimize areas of this code that are not going to run even in the order as we see them in the screen. So even if we don't want to go in that specific detail, again, what kind of scaffolding we have when we read this code that we think there is a line. This line is probably associated with time and execution. A computer maybe in our heads reading one line at a time, and so on. So again, metaphors and how we process just this simple line of code. What else? Okay. Are the subjects weird? Here. Do different writing systems engage the brain differently? This is a question asked by Sedivi. I think he's called Julia or Julie. Sorry, let me check. I have the book here, but I have too many books. I don't want to drop anything. You can see. So I don't know where to place this. Here, maybe. Okay, so in this book called Language and Mind, it studies like psycholinguistics, an introduction to psycholinguistics. She cites a lot of experiments. So if you want to dig deeper, you can go to the papers. But she's talking about this study by Jessica Nelson. when they compared Chinese people reading versus English, people that have Chinese as their first language or mother language, and then also reading English versus people that have English as their mother language, and then they read in Chinese. So by the way, if you have questions or I'm going too fast or whatever, just ask in the chat. So what they are trying to see, or what they saw, what they found out, is that the area of the brain that is engaged when you have Chinese as your primary language and then read English, which is your secondary language, is not the same for people that learn English first and then are reading Chinese. So in my case, I used to live in China, as many of you know. When I read Chinese, probably I'm not using the same area of my brain as people that were born knowing, not born knowing Chinese, but that Chinese was the first language. So we are talking about programming languages. Where do we place them? Where do we place languages in this first, second, third language competence of a person? And what about visual languages like Scratch? Do they change the way the brain will work or not? Based again on Chinese was your first language or not. So again, why is it important that we know if the subjects are weird or not? Because these things may change the way we use the brain. Okay. So in the study, in the actual paper I'm talking about, some people knew Japanese, so that was included there. But again, not sure how much this study by Nelson was taken into account. So, first question out of the way: are the subjects weird? Second question: what is code comprehension? So again, what are they measuring? And here, clap, 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 they are very specific. They say, by code comprehension, we refer to a set of cognitive processes that allow programmers to interpret individual program tokens, such as keywords, variables, and function names, combine them to extract the meaning of program statements, and finally, combine the statements into a mental representation of the entire program. This is what they say in the paper. Okay, let's see this in detail. Interpret individual program tokens such as keywords, variables, and function names. So my question is this what compiler books refer as semantic analysis? And if this is actually what they mean, because I think it is, why not use the technical terms used in programming literature, like in compiler design, right? So the book is by Aho et al., and it's called Compilers, Principles, Techniques, and Tools, and it's from 2007. For those in programming, it's the Dragon book that, yeah. Anyway, so, because when we say code comprehension, okay, well, what do you mean by code comprehension? Okay, what this paper was measuring is not any kind of program, any kind of activity related to programming, because we can say debugging is an activity in programming, modeling is an activity, whatever. They are specifically measuring basically what you will call semantic analysis, which is reading a piece of code by a compiler or a parser or a human being, and identifying that you have, how you call that? You have a function, a code comment, a for loop, an if statement, a switch statement, a class declaration, a package declaration, whatever. So this is what a parser is doing. It seems what they're measuring is that specific activity. So that's one thing. Now, to highlight some stuff in this extract from the paper. They say, interpret individual program tokens, extract the meaning of program statements, and finally combine the statements into a mental representation of the entire program. So another question I have is, Is this process happening in that exact order? Are we really, as humans, parsing tokens, then, and I'm using the word then extracting the meaning of these statements, and then combining the statement into a mental representation of the entire program? Is that really what we do? I'm not sure. I think there are studies that do eye tracking that maybe show a different picture here. And different picture, no pun intended. So, is it possible that for some problems we recognize a structure without the need to parse individual tokens? So in semiotics, there is the idea of icons. So when we communicate and we exchange signs, like that's basically the main object of study of semiotics, signs. There are three types of signs, which is symbols like words, icons, which could be a picture, like I see a picture of a person, and I can understand that there is a bathroom stall in a supermarket, let's say in a shopping mall or an airport. I see a plane departing, I say, okay, departures is in that direction. These are the icons. And the other one are indexes, which we can talk later when we talk about the meaning of programs, but now let's focus on indexes. So an index has a resemblance to the thing that it represents, and represent, make present again. So the sign of the toilet is telling me, is making present the idea of the toilet. In this case, if we consider, question, can we consider the structure of a for loop an icon that resembles like an ideal for loop in our brains? So when I see a for loop, I immediately know what this is, what the icon of this is, without actually reading the code of the for loop, without reading what's inside the for loop. So I just recognize immediately that there is a for loop. So again, is this taken into consideration? In semiotics, it is. But here, when we are trying to understand how we read code, we humans, do we recognize simple things, or maybe we just see structures, and when for some reason we want to know more, we go into the structure and the individual tokens, and then we go up to the macro structure? I don't know. But at least, from my point of view, for loops, if statements, switch statements, class structures, all those things are what in semiotics could be called icon. And by semiotics, I mean the one by, I forget the name, Roman Jakobson, and maybe later Eco, but specifically the division made by Roman Jakobson, which I think maybe was the first in saying sign, icon, and index. But to not get too much into that detail, so is this process that they describe in a very linear and consecutive way? They are like interpret tokens, extract meaning of program statement, combine to make the picture, the mental image. Does this really happen in this order? I'm not sure. I don't know. I'm not sure. My guess will be it depends. Next. Then they say something that they say, combine them to extract meaning of program statements. Now, what is the meaning of a program? I think this is a non-resolved question. I will go deeper into this at the end of this stream. But that is a very, very complex question, meaning. And it hasn't been solved in the last 100 years. I don't think I will solve it for sure. But it's not a word to be used lightly when we start talking about interpretation and so on. But again, this is a hard question. Let's leave it for later. Then, something that has to be addressed, even if it's not what they're trying to measure. When we read code, when, because I don't think this happens all the time, but what about when we are playing computer in our heads? So we start reading code, we make like an hypothetical computer in our head, a model computer, and based on that computer, we try to understand what the code is doing. So Knuth, in the art of computer programming, all his algorithms work for the specific MMIX computer that he defines in the first volume, or in the first volume, yeah. So, what happens in languages that have virtual machines? What is this ideal computer on which we are contrasting the code against? What about languages that have JIT or GAT compilers like Java or PHP today? What happens there when the code that we write is not what is going to be executed by the machine? Or Erlang or Java or whatever. So, on one hand, we have the code in the program. On the other side, we have the actual computer that is running the program with its own architecture and whatnot. In between, we have an ideal computer that the programmer is trying to think how it will match the program. In many cases, we just don't care about that because we are actually running a higher level programming language for a reason, because we don't want to care. But if you're writing a compiler, you're writing a programming language, or you're writing high performance code, you need to care. You need to care about memory structure. You need to care about the operating system, how threads work. You name it, you have to care. I actually had problems at work where you really, really need to consider where the code is running. So again, this might not be measured what this paper was trying to measure, but at least is this model computer in our heads influential to the measurings, and how this varies according to user experience as programmers, like this image of computer, how does it change between different persons? So yeah, I don't know what when I try to see what the code is doing with that activity, because one thing is reading, one thing is understanding what the code is doing. When I start doing that exercise mentally, what is happening with this model computer, let's say? Again, as we do in Uruguay, I don't know, okay? So, what else? Do the results apply to non-imperative programming languages? Even if Scratch is a bit different, from my point of view, it's still an imperative programming language. So how do people will read programs that don't have variable that where variables are immutable, like in Haskell? What happens when the equal sign stands for pattern matching, like in Erlang, and not variable assignment? In Erlang, when you have the equal sign, if the variable is not bound, as it's called in Erlang, whatever is to the right side, my hands are probably reversing the screen, but what is on the right side will become the value of the variable, as in most programming languages. But if the variable is actually already bound, so it already contains a value, the equal sign is actually matching the other side. So you can say n equals 7 and n is empty, so n becomes 7. If you say n equals 5 on the next statement, you are not assigning 5 now. You are matching. And Erlang will return an error because 5 is not 7. So how does this changes when people read code? Or it's just a different language? But okay, that is a very basic example. What about loops? Because a problem that imperative languages have, mostly those deriving from Algol, is that they are even if they're high level, they are still very close to the machine, in the sense that a for loop is a very low level operation. An if statement is a very low level operation. What happens when we read logic programming, like in Prolog, or when we read a map statement or a fold or expression instead of a for loop? What happens when the accumulator in the for loop works similarly to the index variable, not always, but similarly to the index variable in the for loop, or to what the code inside the for loop is actually changing in each iteration? That in the fold is a fold variable. So how does this changes? Is it universal across programming languages, the way your brain reads and works, or the higher level the language, we engage in different activities? Because programming language, the syntax in a way is the interface, the user experience, the interface of the language is there. And this interface is what the user is going to use to solve problems. So how is this limiting? How is this, for which problems is easier one paradigm or another? What happens with programming languages like Mozart OS, which is multi-paradigm? I don't know. But I think it should be clear, at least from the paper, that we are measuring an imperative programming language. With that is enough, I think, to clarify what they are measuring. And a good paper to think about this problem is, can programming be liberated from the von Neumann style? This paper was a Turing Award lecture from Bacchus. Bacchus is the inventor of Fortran, or creator of Fortran. So it discusses what is the von Neumann style doing to us when we program, what are the limitations, and he proposes kind of functional programming language. I'm not saying that functional is better or imperative is better. That discussion makes no sense, actually. What I'm saying is, are these studies affected, or will they be affected if they study functional programmers, just to give an example, or logic programmers? Then we will see later some of the example code that they actually measured. Is very basic code, very basic. We will see it later. This is not against the paper. The paper actually comments at the end, I think, that they say our code is very basic, and this might be different in more complex code using classes and so on. But I think that the code they present has a problem. I think it has, is that they are measuring one-to-one mapping problems. And one-to-one mapping problems, from a semiotic perspective, are not the same as problems that require some sort of abstraction. And I will explain this soon. So what do I mean by this? Math and numbers, or numbers, let's say, there is another great book that discusses the numbers from this cognitive aspect, also by Everett, the author I quoted in the beginning about the weird people. And the idea of 7, that's an invention by humans, or let's say 8. Yes, there's going to be octopuses with 8 legs in nature, but the idea of the number 8 is just a creation, a tool created by humans that is very useful. And as he said, there is people, and numeric people, that they don't have numbers. So whenever we talk about very specific math problems, math as in arithmetic, like some of the ones used in this paper, we will, as I say, I will show them later. They are, I don't think they are going in too deep into semiosis and interpretation. So, not sure this is, when we have a map is not the territory kind of problem, which I will explain soon, what happens there? Because they also talk about music in the paper. some related results on how people read music. But again, this is something that Eco explains in the theory of semiotics. Music or music notation and parentheses. We are discussing in general. So far we are discussing notations. Programming languages, even if they have the word language, they are notations. Math is another notation, and music is another notation, which is not the same as language. And this, you can read about this in the book of Grammatology by Derrida, and actually the commentaries by Spivak, the author, the translator of the book into English. The book was originally written in French. Chakraborty Spivak, I think is her name. Sorry if I butchered that name. But she translated the book into English and added a lot of notes to the book. And one of the notes is about notation. And she cites a really interesting paper that discusses that in the 50s, programming languages trying to attach to the wave of linguistics being cool because of Chomsky, which was famous back then, programming languages became languages. Before they were not called languages. So again, this metaphor of calling programming languages is also, we need to understand, it's a metaphor. We are in a heavily written kind of culture. Some cultures don't write. I'm like writing and reading. That's why we take as natural, I think, notations like programming, math, and music. We think it's just another thing, but we don't see that these are just notation, not language itself. So in the case of music, back to the discussion, what Eco says in the theory of semiotics is that if I see a sol or a G in a pentagram, I know I need to press this key on the piano, one-to-one mapping. I see an A or a La in the pentagram, I press the other key on the piano or guitar or singing or whatever. So again, that is a one-to-one mapping sort of problem notation. So the replacing you are doing, or we are doing, when reading these things, we're reading the number 7. What is the problem with numbers? Numbers are not abstractions in the sense that the word cat is an abstraction. The word cat is an idea that stands for all the cats in the world, which I can, by reference, say, no, I'm talking about that actual cat across the street. But the word cat removed a lot of things that are part of the concept of cat. And that is what makes actually language or languages useful, that this abstraction and this possibility of substitute for things or stand for things, represent, make present again, is what makes them useful. And in the case of 7 and musical notation, I don't think that mechanism is in place. This is more complex. We could go there, but let's try to keep going. So, music is a one-to-one mapping problem, yes, and then when we do data structure implementation, a data structure is not bringing a problem from the outside world that we try to model and then make a linked list or a map or finger tree or whatever, you name it. So what we represent in the computer with the code is this idea of the data structure. Again, a one-to-one mapping problem. So even if a data structure is more complex in presentation than the code they use for the tests in this experiment, I am not sure again about if they go into linguistic areas because of the one-to-one mapping problem. So let's keep going. So what are these map-to-map, this not one-to-one mapping? Is basically when you enter in the map is not the territory situation, when you need to model. Like in this book, Data and Reality, William Kent discusses if you are trying to implement the also high Froyask. No, I don't know how you pronounce that. If you try to do modeling of the inventory, you need to start doing some sort of abstraction of, let's say, what is a piece, what is an item in the inventory. If you are discussing what you have for sale, you maybe have an item and the number of this, let's say, a bottle of water. So or maybe not the bottle of water, but he put the example of a screw. We have a hardware store and we have a screw. So if I have 2,000 screws or 100 in the database and in my code, I will have a class, let's say, called item, and it's type screw, quantity 200, let's say. But if I'm trying to track pieces that are returned because they are failures, I need to identify the exact piece. So here I care about that specific screw, and in the other one I care about screws in general. The point being that in this kind of problem, the more complex they become, and the more complex the modeling becomes, because we will start having classes and so on related to each other, we start having this sort of map is not the territory problems. And these problems also refer back to the real world, not like the world 7. So when I refer back to the real world, I engage what Eco, Patricia Violi, and many others semioticians call the encyclopedic knowledge of the reader. We have some sort of encyclopedia. They say that whenever we talk, all the things that you learn since you were born and that you remember, that is, let's say, your encyclopedia. So if I say in a book about literary theory, and this is also related to Derrida's ideas of difference, if I learn the word pink, and I see a heart, okay? In my encyclopedia, pink and hearts may be related, like a heart from Valentine's Day. Valentine's Day, that is not something that is part of the, let's say, Uruguayan culture. It's more like an American thing. But thanks to my encyclopedia knowledge, now I know that Valentine is maybe a node apart. So I have Valentine's, hearts, color pink. But then one day, says this author, I see a pig, and I know that the meat of the pig is also pink. So pink, the idea starts to have all these connections in this network, and this makes the encyclopedia. On each instance of language, whenever we are speaking, Eco says we do some sort of abduction, that is a logical way that we go into a hypothesis without proof. So if I say the word, let's say, chat or chat, if you see this word written, I can write it here in the chat. if you see that word, you will make a hypothesis of that I'm talking about actual chat, like as in online messaging. But if it was French, I will be talking about cats. So due to our encyclopedia, we hypothesize that this person is using the English word that is talking about chat and whatnot. So when we have this kind of map is not a territory problem, we engage the encyclopedia, and I don't know what kind of neural connections are at work there, which is not the same as, again, one-to-one mapping problems. So let's see the code used in the study. The study has, you can find the code on GitHub, it's linked on the paper. Just go to the paper, find the GitHub, and you can see the code. So this is one of the more complex problems that they show in this paper. And then there is another one like that, and this goes up to 15 or something like that, I don't remember. So a question I have is about the shape of this code. You can see that this code has a given section and this happens kind of section. So given the values, numbers, and answers, 4 values in number, answer, append, blah, 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 and print answers. Or 4 values num and sum num, for n in range, blah, 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 do something. So there are 15, I think, problems like this one. And again, this is very basic. You can see there is no complex code, let's say, like in a class or stuff like that, which the authors, they mentioned that in the paper. So my questions are, is there some priming in the way that problems are presented? So if I see one time this code, next problem is like that, the other problem is like something else, right? Again, and let's say some tiny details are changing, but in general, it's the same shape. I mean, I don't know how this was presented to the people they studied, okay? But maybe some other paper is thinking about doing the study and they can take this into consideration. My question is, how this shape or structure in the code will change the way I read? Because for me, the second time I see this shape, I already understand that you are showing me some variables and some for loop and you're printing the stuff. So depending on what you're asking me is what I'm going to answer, or what if you will even bother reading the rest of the code. In this case, if I saw that and then I saw that, I will only focus on the sum, num plus equal n, the body of the for loop. Because if I need more information to understand what happens there, I will go out. Also, from math knowledge, we know what a sum is. We have used sums probably in Excel, which also there are articles that discuss Excel as a programming language by Feline Hermans and more people. So how is that knowledge that I already have, this encyclopedia in a way, just helping me to ignore the rest of the code and not even read it, because I don't need to think that this code is printing because I saw it on the first one. I don't need to think about the given. I just check inside, oh yes, it's doing a sum, adding numbers. Next, show me the next one, right? So if maybe changing the shape of the problems, doing different kind of for loops, I don't know. Again, I'm not sure how they use these examples in each of the tests. But I think it's something to take into account. If they had taken this into account, then better. I mean, there's no problem there. And the second thing that happens is, does the user engage in a fill-in-the-blank type of situation? You know, when you are learning a new language and then you have the dog is barking, the cat is meowing. So you know that when it says the bird is, I don't know, singing, you know that will go a verb there, and you don't even care about the structure of the exercise, because you know that you are just filling in the blanks. In this case, filling in the blanks is just knowing what the sum is doing, right? Nothing else. So again, does the shape of the code shown doesn't make me at some point just start cheating, let's say, because of this, right? And now we come to the hard part of the study. And this should be over soon because we are over an hour, or we are actually reaching an hour. So what do they mean by meaning? There is a book about different semantics. So basically, what do words mean, or what is the meaning of a sentence or of a text? Is the context surrounding the text important or not? Does the words being used need to refer to the real world or not? Is the meaning intralinguistic only, so only to be searched in language, or also language and outside language? So there are at least 3 schools with this kind of questions. You can see that book I mentioned there by Patrizia Violi, Meaning and Experience, is from 2001, discusses all these ideas. So that is just about the word meaning. Again, we don't have time for that, literally. But what do you mean when you say meaning? And then what do you mean when you say meaning of a program? And where is the meaning of a program? And let's see some examples. So I have a class animal, and it has a method called getName, right? So what is this code doing? What is the meaning? What is happening here? Is name returning Champ, Toto, or whatever name your dog or cat has? Is talking about the species like dinosaur, cat, unicorn. Okay, because if we think that the result value of a program is the meaning, first we'll be surprised about what happens there. Again, we see later. But the result, whether it returns champ or cat, let's say, will tell me which will basically give me context to I forget the English word. I also the Spanish one. To shorten, let's say, the range of getName, okay, or name in this case. So I know, okay, this function is called getName, but it's talking about the species of this animal, not the actual name, like the actual given name to the animal. That is something I can take from the return value. But does it mean that the return value is the meaning of the program? Does it mean that knowing what this for loop with some summation is that the meaning? What is the meaning? The final result, or that it's just doing a summation? That is the question I'm trying to ask. And when we read in literary theory, we have something called paratext. A paratext is something that helps us understand things. If they say, like, how can we understand that Ulysses by Joyce has a parallel to the Ulysses by Homer, the Odyssey? If I don't know, Joyce's book is called Ulysses, just to give an example. But how does this relate to code? What if I had on top a package that said fiction? If the package says fiction, I know I'm talking about fictional animals, and then in this case, I can expect things like unicorn or behemoth to be returned, but not cat or dog, right? Like in the case of fiction. So why does all this matter? Because all this extra context we start having in the code is helping me understand the meaning of the code, whatever that is. And again, this is not just inside one, it's not inside the function code, or maybe it is everything contained inside the function code. What happens if I have a square function, a power function? Question. I got lost by that kind of spammy message. Yeah, so if I have a power function, okay, so I know the function is returning the power of something. But it uses the simple power algorithm presented by Knut in Art of Computer Programming, or it's using a matrix, using matrices to calculate the power. That changes the actual program. So maybe one is inside, I don't know, arithmetic, and the other package, and the other one is inside the matrices package. So is just the function code what matters, or is the whole thing that matters to understand program? And how do I get all these things? How do I connect these things together? Did I do a parsing of the whole program? And I saw tokens, like semantic analysis, like they say in the paper. So I saw package, fiction, class, animal, blah, blah, blah. Or I just went directly to the method and saw what the method was doing. I didn't get enough information about what kind of animal this method was talking about. So I went out and looked, oh, yes, it's fiction or it's non-fiction, let's say. Right? So next... is let me see, what do I have here? Yeah, and then also about the meaning of a program. If I run a test, okay, where I load this class, let's say this class had an initialize method where animals are being loaded from a database, right? But in the mocked version on the test, I just load them from a file, and one of these animals in the file is SDF, because I don't care. All I care is that the class animal is able to load data and populate an array correctly, so I can then check if name returns something that is expected to be inside the array. What is the meaning now? What happened to get name? Again, so it's not so easy to answer this get name question. Then is and this is the final slide, by the way, is the result of a function the meaning? Like, I've seen some papers claiming that. Well, I can have a function called square that has inside a hard-coded return 25, and if I run tests, as long as I pass the value 5 or minus 5, that function is correct. Now, is it really working as we expect? Or what if I have a function called random and say returns 3? As Knut says in Art of Computer Programming, 3 or 7, I don't remember which number he uses, that is a perfectly random number. I just came to my mind. I can say 15, 17, 1, whatever, right? So that function is returning a random number. Of course, he gets serious later and implements a pseudo number, random number generator. And he uses I think it's called the arithmetic progression kind of random generator, which is modulo and whatnot. That method is not safe for today's computers. So Java and so on, they use a different method. Let's call it the cryptographically safe method. I don't know. I can link to papers later. But the question is the meaning of the program just the name random that is telling me that I'm returning a random value? Do the random numbers being returned tell me something about the actual program? I think yes, they do. They give you specific instances of what happens so you can contextualize better what random means. And the code itself is just telling you which version of random we are referring to. So again, meaning is a very, very difficult problem, let's say, to see what is the meaning of a program. So were they measuring in the studies to see if a person understands that the function is returning 25, is returning all square numbers, is returning for 3 returns 9, for 9 returns 27, whatever, right? I don't know, but it's not an easy topic. So these are some of the questions I had for this paper. Let me know if you have questions. Otherwise, we can see later on Twitter. Ask me questions there. Tell me what you think. And I will also upload the video later to YouTube. So thanks for hanging out. I know it was a very geeky discussion, all in talking about geeky stuff, like from programming to linguistic, neuroscience. Some topics, as I say, I am far not from expert. I'm not even a beginner in most of these topics, okay? So this is kind of what I wanted to do based on questions I had from that paper and other papers, as I said earlier. So yeah, let's chat on Twitter if you want, and I will share the link to YouTube later. So thanks again, and see you later. So as I was to cut, there is a new question by Jenna, or Jenna, I don't know your name, sorry. And she says, I think or they say, are there any code examples where the variables are given nonsense name versus variable function name that are meaningful, helpful in understanding the program? Okay, yes, they try that. And actually, I think they even use Japanese. But this, I think, falls into the fill in the blank kind of situation, because you have grammar also. And grammar or syntaxis, in this case, can tell you A equals 7, something equals 7, A, B, C, D equals 7. Doesn't really matter, because you know there is variable assignment value. So they did try that, and they saw that, yeah, the results of their paper is not affected by that. But which is kind of expected, because as I commented on the for loop kind of structure thingy, I think we recognize shapes, and we know what goes where. And they saw this in their studies. So yeah, there are code examples where they try that, to use nonsensical stuff. But it happens with code. I can say Twitch is blah blah. You don't know what blah blah is, but blah blah is it's probably an adjective. And if I say Twitch is blah blahing, you will guess that Twitch is doing something related to blah blahing. I don't know what that is. And that's, they know that, the authors. Also, they know that it's not the same neural path are related to reading like complex paragraphs versus reading one sentence. So that has been studied already. Yeah. So any more questions? I can stay. I have no problem staying, but just I don't want to leave anybody hanging. If not, I'm just sharing while maybe you think about a question. My plans, besides publishing this on YouTube, is to maybe share a critique, like a written critique with the authors, basically outlining what I just mentioned here. And I want to create an article that kind of formalizes these questions. So the future papers, they could keep them into account, because this is something even the author of these papers noticed as something that the older papers were lacking. It was not clear what they were measuring. So in the hope that this will be improve the research, let's say, I want to formalize these questions, have them like very clear in an article, so they can be taken into account in future studies. So if you don't have any more questions now, yes, we see on Twitter.